Simply put, the transpose of a matrix is what you get when you swap its rows and columns. Transposing a matrix is one of the simplest yet most important operations in linear algebra. It is something people often get wrong, so it's worth creating a video to understand it better. You start with an M times P matrix A. Its transpose is P times N matrix. The elements on the main diagonal stay in the same place when you transpose. That is because each of these elements lies where the row index equals the column index. If you imagine each matrix entry as a square, transposing is like reflecting the matrix across its main diagonal. If you think of the matrix as a table, then transposing is just flipping the rows and columns. Now suppose you write matrix A as a collection of column vectors. Then transposing means turning each of those column vectors into corresponding row vectors. For example, the first column of matrix A becomes the first row of A transpose, and the second column becomes the second row, and so on. Likewise, if you think of the matrix in terms of row vectors, transposing turns each row vector into a column vector. For example, the first row of matrix A becomes the first column of A transpose. The second row becomes the second column, and so on. As we mentioned in an earlier video, transposing a column vector gives you a row vector, and transposing a row vector gives you a column vector. If a matrix is tall, meaning more rows than columns, its transpose will be white, and if it starts white, the transpose becomes tall. When you transpose a square matrix, it stays square, but the elements reflect across the main diagonal. And for symmetric matrices, the transpose is exactly the same as the original. The shape of the matrix might change when you transpose, but the rule stays the same. Rows becomes columns, columns become rows, and all relative positions stay intact. From geometric perspective, suppose A is a 3 times 2 matrix. Its row vectors can be seen as 3 arrows in the plane, and its column vectors as 2 arrows in 3-dimensional space. After transposing, matrix A transpose has 2 row vectors in 3D space, and 3 column vectors in the plane. Be careful, transpose is different from reflection. Transposing is specifically about switching rows with columns. Also, the main diagonal isn't just any diagonal. Matrix transpose is not a diagonal reflection, and transpose is not a left-right flip nor a top-bottom flip.